All right, so here's a homework video. So if you want to do your homework with me, here it is. First, can you write reciprocal functions? So if you translated 2 to the left and 9 down, what would that look like? So no reflections, no stretches, so it's 1. And now 2 to the left, we do the inverse. We're going to add 2, and then 9 units down, we subtract 9. That's it. Here, reflected across the x-axis. So already I know it's going to be -1 because of the reflection. Translated 5 units up. So the denominator stays the same, no shifts left or right, and we just add 5. Number 3, vertically stretched by 4. So that means the numerator is 4, and then 3 units right means we're going to subtract. Vertically stretched by 2, reflected, so already I have a sense it's -2. Then it's translated 1 left, so I go +1, and then 8 up, so +8. Done. Here are some with just asymptotes. So with this asymptotes, I just go x subtract 3 and then subtract 2. Here again, -7 +7, and then 0 means I don't add the 0 at the end because it doesn't change it. Done. So recognize that the denominator affects the x, and it's the inverse of what you see, and it just takes practice. The numerator and what's after the fraction affects the y, and it does what it says. All right, so now let's see if we can graph again. For these, we start with the parent points, 1, 1, -1, -1, x equals 0, and y equals 0. And then I look to transform them. So in the denominator, I just see x, nothing changed. So the x does not change. In the numerator, I see a 1, so times 1 doesn't change, but I see +3. So that means all y's are going to add 3. There's a vertical shift, up 3. So 1 + 3 is 4, -1 + 3 is 2, and 0 + 3 is 3. I'm going to plot these points, so 1, 4, and -1, 2. Oops, yeah, add 0. And the other one's at 3. And know the end behavior, and then at the asymptote. So the above one goes to infinity, and the one below goes to -infinity. Here, the domain x cannot equal 0, and for the y cannot equal 3, and those are also your asymptotes, because it shows where the graph is undefined. 8, all I see is a -1, so for the parent, it's just the y coordinate, and it becomes negative. Now, a negative times a negative makes it +1, but the zeros don't change, so like 0 times -1 is still 0. So I just went right and changed it, because it was so simple. So every y coordinate times -1, and that's why it changed. So 1 and -1, -1 and +1, and then the asymptotes are y and x 0. Know the end behavior goes to the horizontal, and then the vertical asymptote, the above one goes up and the lower one goes down. The domain, again, x cannot be 0 and y cannot be 0. Those are also your asymptotes. All right, turn the page. Press pause, of course, if it's going too fast. Number 9. So for this one, I'm going to start with the parent, 1, 1, -1, -1, x equals 0, y equals 0. And then I notice only the denominator has changed. I do the inverse. So I'm going to add 4 to every x. The y has not changed. So times 1, nothing after the fraction. So it stays 1, stays -1, stays 0. Plot the points. So 5, 1. And 3 and -1. Asymptotes are at 4 and 0. No, the end behavior goes to the asymptote, and then at the vertical asymptote, what's above goes to infinity, what's below goes to -infinity. So the domain, x cannot equal 4, and y cannot equal 0. That's also your vertical and your horizontal asymptote. Number 10. Again, press pause. Why don't you try number 10, then press play? That'd be a good plan. All right, if you want to do it with me, 1, 1, negative 1, negative 1, x equals 0, y equals 0. So look at the denominator. So the inverse. So we're going to subtract 2 to every x. So that's negative 1, negative 3, and negative 2. To the y's, I have to do two things. So I circled them. Times 3, and then subtract 1. So 1 times 3, subtract 1. Negative 1 times 3, subtract 1. And then 0 times 3, subtract 1. Now I'm going to plot the points. So negative 1 and 2, negative 3 and negative 4. I'm going to put down the asymptotes. So we have an asymptote at negative 2 and another one at negative 1. And remember the end behavior. So the both ends go to negative 1 just on opposite sides. One comes from above and the other from below, but they end up in the same spot. And then if it's above, it goes to infinity at the vertical asymptote, and if it's below, it goes to negative infinity. So again, where are the asymptotes? So at negative 2, and the other one is at negative 1. That shows you where the graph is undefined, what it can't be. The vertical asymptote is negative 2, and the horizontal one is negative 1. All right, it's your turn. Try it, then press play. So we're going to start with our parent. Look at the denominator. Because it didn't change, it stayed, all the x's stay the same. For the y, I look at the 2 and the negative 5. So 1 times 2 and subtract 5. Negative 1 times 2 and subtract 5. And 0 times 2, subtract 5. I'm going to plot these. So 1 and negative 3. Negative 1 and negative 7. I have a horizontal at negative 5. Oh, this one has to go one lower. There it is. And then another one at 0. So it's the one that's a little bit below. There it is. This one was a little high. So there's the curve. And you can see the end behavior and the behavior at the asymptotes. The domain, x cannot equal 0. And the range, y cannot equal negative 5. The vertical asymptotes are x equals 0, and the horizontal asymptote is y equals negative 5. All right, number 12. Start with the parent, and then transform. In the denominator, I'm going to add 6. And then negative 1 to the y. So it's negative 1, positive 1, and stays 0. Because 0 times negative 1 is 0. So find 7, negative 1. And 5, positive 1. We have asymptote at 6. And then at 0. And then curve it. So at the asymptote, it goes down forever and up forever, and then it follows the horizontal as the end behavior. The domain, the only number x cannot be is 6. For the range, can't be 0, and that's also my horizontal and vertical asymptote. 2 more. You need to practice if you haven't done it yet. It's simple enough. Try it, then press play. 13. Start with the parent. Transform it. So we're going to add 1 to each x. And we're going to go times 4 and subtract 2. So 1 times 4, subtract 2. Negative 1 times 4, subtract 2. And 0 times 4, subtract 2. So we're going to plot these. 2, 2. 0, negative 6. We have a vertical at 1 and a horizontal at negative 2. And then the curve. So it goes up forever and down forever. And then the curve. So the end behavior is the horizontal asymptote. Again, x cannot equal, what is it, 1, and y cannot equal negative 2. That's also your horizontal asymptotes. All right, one left. Press pause. Do the work, then press play. So the denominator, we're going to subtract 5. The numerator and what follows it. So times negative 3 and add 4. So 1 times negative 3, add 4, that's 1. Negative 1 times negative 3 is 3. Add 4 is 7. 0 times negative 3, add 4 is 4. All right, so plot these. So negative 4, 1. Negative 6 and 7. We have a vertical asymptote over negative 5. And then at 4, we have our horizontal. So we know it, the end behavior and what happens at the asymptote. And we're done. So one thing people can make a mistake on when graphing is they curve it in a way where it curves back, like it looks like a C. This does not look like a C. It's not curving back around and making a C pattern. So one arrow is going to each one is going to the asymptote. And if the arrows aren't following the asymptotes, then we're drawing it incorrectly. So don't draw a C where this curve starts to come back around. So the ends of the arrows follow the asymptotes. All right, so x cannot equal negative 5. Y cannot equal 4. Those are also your asymptotes, and you're done. You did the homework. Can you analyze and graph a reciprocal function? Yes, you can. Mr. G Math, over and out.